Hey everyone, welcome back to Ground Zero. This is episode 11. Today we have Lucas and Varun from Arcee AI. For those who don't know Arcee, I think I pronounced well. They started
Yes.
as a post training company doing model merging, fine tuning, track pipelines, and then at some point they made the call to build their own models from scratch, pre training, the whole thing. They shipped a 400 billion parameters sparse MOE called Trinity, trained it on, if I remember, 2048 B300 GPUs
Mhm.
in about 33 days, spent around $20 million. That's crazy across four models in 6 months, and released everything under Apache 2.0. The model went on to become the number one most used model in the US on Open Router. So, yeah, I think a lot to cover today. Lucas, Varun, welcome. Glad to have you on.
Nice to
Yeah,
be
thanks
here.
for having us. Yeah.
Awesome. Probably I want to start with the people before we get into the more technical stuff. Varun, your path is pretty interesting to me, and we have got question as well from Sankal. You went from software engineering to leading pre-training at a lab that's now shipping frontier models, and you being the integral part of it, looking over the pre-training side of things. And I don't mean this as a career advice question. I'm curious about the actual story. What were you working on before? What pulled you towards this? And when did you feel like you could actually do this at the level?
Yeah. Um, I've always wanted to work on AI since like 2017 roughly. I think I like discovered like a YouTube video about it, watched some MNIST tutorials, all that stuff. Um, During college, I took a lot of like your standard ML courses, intro to ML. One funny thing was that I was actually in a deep learning for NLP class during the launch of ChatGPT. So like my professor was freaking out during the
Yeah.
launch and like showing it off at every tone. And I guess that's what it really brought LLMs to the front of my mind. But even back with like GPT 2, GPT 3, the playground on OpenAI, I always thought that was interesting. Um, when I did my masters, I like did distributed systems in ML as well. So it's like and I took a course for like uh, ML distributed systems in particular. So I always thought that was like super cool as well. So I guess I always like saw working on this sort of thing as like something I wanted to do. Um, so I guess when Lucas reached out, it was like a no brainer for me to jump and join RC and take this crazy bet. Yeah.
I mean, what was the hardest adjustment going from engineering to completed research, according to your experience?
Um, I think the biggest adjustment wasn't so much in like the the technical side of things necessarily. It was just like going from a big company to a startup. Because at a startup, things are much more loose. You have to do a lot more, work a lot more, and you really have to like kind of be aware of so many moving things at the same time. So I think that was probably the biggest adjustment for me
I'm
personally.
curious if something went wrong at scale during this training or
Oh yeah,
your
yeah. We have a whole section about it in our paper actually. I think towards the end, uh, you know, we kept seeing expert collapse, routing collapse, and eventually we had to just like we had like I think 5 or 6 different fixes that we all like sort of briefly tested and just threw it in there and just to stabilize it. And that was probably one of the most stressful weeks of the training run. Yeah.
Awesome. Lucas, my question to you. So you wrote the Trinity Manifesto, and there's a line in there that just says, "It's fucking hard." That stuck with me. So what was the lowest point during the whole Trinity process? If you want to highlight.
It's funny because I wrote that actually before we started large, or we had just gotten the cluster and we were starting up large. So the failures that Varun is speaking to had yet to take place.
Mhm.
I don't, it's not one thing in particular, right? I think it's just that um, I wrote this to the team last week after we launched, but we had been we obviously brought Varun on early 2025 because Mark, the CEO, and myself had thought, I bet we could probably do pre-training really well, and I bet we could do it for pretty cheap. Like we had a lot of this is even prior to like the R1 and V3 paper where the initial kind of I wouldn't say propaganda, but it's the closest word I can think of at this moment as to how much training these models actually was kind of there's a lot of misinformation out there. People were throwing around like $1.5 billion numbers for like Sonnet 3.5 training, and we knew that likely wasn't the case, but it wasn't really until the first one came out. We did a dense one, that wasn't as architecturally complex
Mm-hmm.
in July that we kind of really had this moment where we decided we were going to go all in and spend a significant portion of our capital on doing this. And so it wasn't one particular moment that preceded that line of it's hard. But I do think that um, there are a lot of sneaky. I mean, from the context of us coming from a lab that used to do a lot of like post training research and trying to kind of push what was available with like open tooling there are a lot of sneakier failure modes than in post training. I think that
Mm-hmm.
when you're starting from an already pre-trained model, you have the understanding that you are usually, if you've chosen the right model, starting from like a known good checkpoint, and that like
Yep.
it should work. You know how its evals are. You can eval it beforehand. You know you have reports and a lot of help from the community and collaborators in ensuring that the tools that you're using for post training, whether it's Unsoth, Axolotl, Llama Factory, um, support that, and that others have had good success at least with that. So there's not as many unknowns. There's obviously things that go wrong, and you have to figure out how they work on your specific setup. But pre-training in particular, especially when we made the call to do quite a lot of different things architecturally than just raw DeepSeek
Mm-hmm.
v3. There's a lot of error, failure modes in ways that something can sneakily go wrong that you might not have built out tests or regression tests to observe. So less so like any individual thing was hard. They were all very hard, and that kind of informed that phrasing. But I think the overall uncertainty of any kind of run, at least for people doing it at that scale for the first time, is
Mm-hmm.
particularly anxiety inducing.
I mean, yeah, totally makes sense. So on the lighter note, so you're pretty deep in the Openclaw system now. So Trinity was powering a huge chunk of open order traffic. So do you have your internet claw names? What's the culture like around testing agents internally? And I recently have seen the spike has been toward Hermes agents as well. So how's it been like?
Oh, yeah. So when we did preview, we launched before we launched the one that came out last week. So that would have been April 1st actually. We released a kind of an instruct preview version of large because we wanted to get it out before Chinese New Year.
Mm-hmm.
Um, and yeah, it kind of hit this perfect moment where that launched, and Openclaw was starting to hit its stride.
Yep.
We were really surprised at the usage from that because while we had targeted to be a good model all around, it was not something we hadn't targeted like Openclaw in particular.
Mm-hmm.
Funny enough, I mean the culture at RC is not crazy Openclaw pilled. We I think part of that is we have been in the mines training these models. Right as they have kind of come, these harnesses have kind of become extremely popular.
Mm-hmm.
So when it came to actually doing a lot of those demos and making the videos that we did for launch and what we've done afterwards, it took a lot of like there were like a lot of like DMs in our research channel of like, hey, like what do people do with it? Like it was very funny.
Yep.
But that doesn't mean that like just because we weren't avid OpenClaw users doesn't mean that you can't make a model that's good in it. I think that when we saw the usage and kind of saw that as like a good, indicator of where the industry is going, whether Openclaw is going to be the thing that continues to grow, or some new players like Hermes Agent or whatever. We knew that like that usage paradigm of like always on 24/7 kind of um, more ingrained assistants weren't going anywhere, and we think that's awesome. I mean, we think that like it's really just such a cool moment that these models are actually starting to match the capabilities that we've been dreaming of, since the ChatGPT launched. But because of that, but there's nothing about making a model good in OpenClaw that's different from the fundamentals of making a good agent. What a good agent means has changed over time. Like it used to just be one that was good at calling a tool, or calling like a tool several times in a multi-turn conversation. Now it has grown into like calling several tools or parallel tools, or even 30, 40, 50, 60, 70 tools before even coming back and talking to the user, over like, drastically increased context. So, the definition of what agentic training means has definitely changed, but the fundamentals of like, okay, hey, we need to make sure that this model is really capable because
Yep.
people clearly like it in there. That was us. We were kind of already on the roadmap for doing that.
I mean, yeah, makes sense. Varun, for you, OpenClaw versus Hermes, any strong take on how they compare, how you compare models perspective there?
Well, I haven't used either extensively, so I'm gonna
Uh-huh.
abstain from giving like a hot take on that one. I've actually been using like models most, I guess, through like more coding type harnesses like open code and stuff. Um, and I think it's really cool. Like, there's just so many good options out there now. Um, so many so many models are capable of like the small tasks, and you know doing a few do calls here and there, that I think it's really a nice moment for the open source community right now.
Makes sense. Let's get back to early days. So basically, the pivot from post training to pre training. As far as I have understood, so you were a post training company. I remember Merge Kit, the like fine tuning rag, and from the outside, it seemed like it was working. So what changed? What made you realize this approach had a ceiling?
Um, I kind of, the funny thing about the Trinity Manifesto was like I wrote that 6 hours before we launched, and thought that that was a cool name. And it's become this thing that people like refer to me. They're like, "Oh, you wrote the Trinity Man," and it's nice. I like that people enjoyed it. Um, but I think that the framing that we were hitting a ceiling. I think if I could go back and rewrite it, I wouldn't frame it in that exact way. But because I think that's kind of where that question is coming from. However, I'll give some additional context for those who haven't read it. Is yeah, we were doing well as a post training company, and the way that usually worked was like an enterprise, mostly
Yep.
enterprises were doing a lot of POCs with OpenAI or Anthropic early on in this kind of LLM boom. They would have a really great POC internally for like some kind of either internal like pilot for improving their efficiency, or a customer facing one, and making their service or product more LLM or AI driven.
Mm-hmm.
But unlike startups, which can afford to, and in this industry kind of oftentimes need to be a loss leader, or like lose money on initial customer acquisition to then figure out how to make the margins make sense later. Public companies don't really have that option. It's one of the reasons it took Google so long to put Gemini and AI in search, right?
Yep.
It wasn't because like Perplexity was so far ahead, though Perplexity was quite impressive. It was that they had to, the market they were serving was so much higher, and the cost per AI search was so drastically higher than their current cost per search. So they could not add that until one was they were closer in pricing.
Mm-hmm.
And because of that, a lot of them would look for early ways to fine tune their own models, or try to take whatever worked with the closed models or APIs they were working with and improve upon them using like open models. And that was either for like an accuracy standpoint, like hey, can we get something that's as good but cheaper. There was a lot that was like privacy standpoint. Hey, we're in a highly regulated industry like finance, healthcare, insurance, law. Um, we can't be giving sensitive information to these APIs, and we would come in and help them do that. Whether starting from like a Llama, and then Mistral, and then later Quinn. I think that a couple things caused us to want to move further down the stack. The first one is, and by far the biggest, was that kind of, and it aligned well with our pre-training, the work that we'd been doing on pre-training already, but it kind of furthered our resolve into doing this, was when DeepSeek came out.
Yep.
Not V3. I mean, it started with V3, but the R1 kind of launch really lit a fire under the whole, kind of like geopolitical argument in AI of like China versus the US. Because up until then, it had kind of been so widely, regarded that the US was so far ahead in AI that China would never catch up.
Yep.
So before that, most companies wouldn't even ask what base model we were starting from. They didn't care. It wasn't even something they thought of. And then immediately once that happened, you had compliance teams and legal teams at companies becoming much more, having much stronger opinions about which base models they started from, which meant that if we were working with a company that didn't want us to start from, like a Quinn model, but we were trying to fit it under like the 14B size range, our only alternative was like a Llama 3.2, 1 or 3B, or even 8B, which hadn't at that point been updated in almost a year. So we didn't like that, that we would be starting so far behind. And like, it was obviously, this industry moves fast. So the better base we can start from in order to reach a capability of like the current frontier models is obviously the best. The second was that fine tuning as a service as it currently looks right now, and it's getting better with where RL is now, but it is currently very services based, meaning very hands on, very unique to each customer. And that meant that if we wanted to 30x our revenue over a couple of years, we'd have to 30x our go-to-market and field engineering team. And that wasn't, Mark and I didn't like that was basically our headcount was going to need to increase, 1-to-1 with how much we wanted to increase revenue. We didn't like that idea. And then, but, to get back to the original point, like we did hit a ceiling as far as if we had set our, say, GPT 5.9, gigacodex comes out and has the most amazing coding scores in the world. And we, at that time, which is what we do, is we'd be like, okay, we want to take a model that's 10B and beat it or match it in performance. If we wanted to do that, we did not want the limiting factor to be like, oh, Quinn 3.14b just hasn't seen enough code tokens or whatever to do that. Like we wanted to have like all resources at our disposal, and owning pre-training definitely gives us that, because it's no longer like, okay, how do we match something, or how do we compete with it, or how do we make something for a customer that is able to perform adequately compared to said model on their internal benchmark. It's just, how long is it going to take? How quickly can we do it, and how much is it going to cost? It's very much a if not how situation, which we definitely prefer.
Hey everyone, so I found this company the other day, Hustle Labs. I hadn't heard of them before, found on my X timeline and interestingly in RN environment list as well. So I looked into it. Let's see what they're building. So they have set themselves in an interesting way. They are solving more on engineering as well as research side, focusing on RL environments, mainly code, computer use, and long horizon enterprise workflows. But underneath, they have a separate talent marketplace as well with 300K experts and their own AI recruiter. Let's see what actually differentiates them out. Their argument is that the hard part of scaling environment isn't just engineering, but it's finding, managing, and the right experts. And they have kind of already solved that piece. I talked to the founders the other day, and they are already supporting frontier labs with RL data. So if you work in this space, research or human data, it's probably worth checking them out. I mean, yeah. What do you think of post training? The scope of post training in 2026? I think we have traveled a good trajectory, like how it started and now how it's going. And most of the companies, or like the companies starting up, are mostly going toward building environments, data, and stuff. So, what do you think? Like, is there any scope building a post training company now these days? And
So
in what direction?
what was
What
the
are the
last?
scope? Yeah, yeah.
Oh,
So scope of building post-training company right now, like in 2026, and what could be the ideas around, like where the, because I think there have been an order of magnitude change, like how it used to be in late 2024 and now in 2026.
yeah, yeah. That came up quite a bit in just the entire, especially when I was speaking to Mark, our CEO, because I kept harping on when we were looking at timelines and spend and capabilities. I kept saying like, well, no, like, hey, we just spent 6 months speed running pre-training. We need to spend some time doing that for post-training too. And he's like, why? Like, we used to be the best public open post-training company. And I was like, it looks nothing like it did. Um, even when we released our last kind of like post train on top of another model, which was like March of 2025. Yeah, it's drastically different, and in many ways for the better, right? You can do RL and generalized RL and RLVR, and even like LLM as a judge. RL has drastically improved, or at least expanded upon the the rate at which you can hill climb on a specific task, as well as the different like capabilities that you can instill in models that otherwise you couldn't have beforehand. Um, I think it'd be interesting to get Varun's take on kind of where he saw it, because he wasn't, he was pre-training basically the whole time when we were doing that, and then he joined us kind of towards the latter end of our post-training sprint. So he's getting a very fresh look on it, especially with Trinity Large Thinking, which he had quite a lot of work on. Even being pre-training lead, he was very heavily involved in post-training. But I will say that it is. I think we're in a much better spot as far as what we can do with these models now. You have wonderful open work out of like Prime Intellect and Slime, and NVIDIA has been lovely about helping push stuff out. Allen AI and their training work is always, those libraries are always outstanding. I will say that it is tougher to enter than it used to be. It used to be that if you had some, good taste and opinions and were able to kind of, have strong intuition about how you wanted your model to behave, if as long as you could afford to curate or generate the data that you think would help the model behave that way, you could. Um, RL post training is very much an infrastructure problem. So I would say that the hosted stuff like what Tinker and Prime Intellect have done with their labs is definitely a step in the right direction, but there are way more variables involved and a lot of checkboxes and fundamentals required in
Mhm.
post training now that are necessary to get a really good model that did not exist back in even late 2024, but especially like early 2023 when open source, kind of distilling a LLMs kind of really took on.
Yeah, totally. I mean, on paint, pre-training side of things, Varun, were you involved in AFM 4.5 run?
Yeah, yeah. That was my
Oh,
first run.
awesome. So, I mean, yeah, your first pre-training run, I think it was some, yeah, 4.5B dense model, some 8 trillion tokens with Datalogy AI. So, I mean, how was the experience? I mean, it was first run. What was surprising? I mean, is something broke, and how much of AFM recipe survived into Trinity? I'm just curious about that.
Sure, yeah. Well, I think the on the pre-training side of things, it was probably my first experience doing like such large scale distributed stuff.
Hmm.
So a lot of the skills I picked up there in like debugging, looking through logs, trying to reason about what exactly happened when the run crashed, how to recover all those things sort of carried over to the rest of the runs. Um, and then just general like general vibes about like, oh yeah, this grand graph looks correct.
Yeah.
This loss graph is basically what I'm expecting to see. Things like that. Um, so I think a lot of that ended up carrying over. The only real difference when we moved to MOEs was like all the unique things to MOEs.
Mhm.
Um, so you have more complex parallelism setups with EP. You have load balancing. I think yeah, that those two were like the big things to move forward. But yeah,
What's
uh,
Yeah,
your view on? Yeah, yeah. Go ahead,
I don't
Lucas.
think he. It should be noted that we didn't really bring the full force of both our partnerships or our internal headcount into these models until after 4.5b.
Hmm.
Varun, there were probably four people of the 11 people on research at the time, myself included, that were pretty heavily involved in the 4.5b project. But Varun was very much like the one owning all the infra. We were working with AWS. We weren't using compute via Prime Intellect just yet. So he really did have to, it was trial by fire there. And there are things that we learned and he learned in doing that that have certainly helped us with later models. I mean, I think one of, when you mentioned at the end, how does Varun, how did he go from,
Yeah.
a pretty typical software engineering job to, leading pre-training for what's now, a frontier class model? I've always been a big fan of like pick extremely difficult things to do that you have no business trying to accomplish, and then bang your head against the wall until you accomplish it. And there is no better way to learn. Now, I don't want to say universally for everyone because obviously people learn differently, but at least for me, and I feel this is true for Varun as well. Like just trying it, like not trying to do it best at first, but just trying and then failing over and over and over again. And then, the idea of like, if you figure out how not to do something enough, you'll eventually like trick yourself into doing it right.
I think this
So,
concept applies to every other, you can say, kind of task. Maybe, I
yeah,
mean, learning by doing.
yeah,
Awesome.
you can
So,
just do things. That's what they
you can
say.
absolutely just
correct,
do
yeah.
that.
Yep. So, Varun, what's your thought on like Ilya said as well? So, pre-training is saturating, right? Like, there are uh, no much big alpha over someone can do a tremendous job in pretending. I mean, there has been talk a lot about this. So, what do you think about this? Like, what kind of problem is pre-training tending to, or how you see it? Is it really a saturation problem, or also, I mean, would love to know your thoughts on mid-training as well. How those pre-training things is going, because so we have stages, how the models are being trained, and if one is saturation, and a lot of efforts are being towards positioning side of things. So, what do you think? Like, how much alpha still pre-training holds, and what are the wide arenas to explore around there?
So so yeah, I think Ilya's big quote was that we're hitting like a data wall, right?
Mm-hmm.
So pre-training is saturating because there's only so much web text you can do. But I mean, since then, pre-training itself has kind of evolved. Even if you look at like data mixes, the Nemotron Super paper had like a great breakdown of their data mixes. If you want a good like modern reference point, but like synthetic data is like the obvious thing that like sort of breaks past that notion of a data wall.
Mm-hmm.
Um, Datology has a paper on rephrasing, and I like to think of rephrasing as a way to upsample high quality things. Um, so that's like one huge area you can like just keep getting better and better stuff. Another analogy I like to think of is like there was one paper that showed that diffusion LLMs are more like
Yeah.
they can make more of like a limited data regime because they kind of if you use the mass diffusion objective, the model kind of sees the data in different ways, right? It's kind of like data augmentation,
Yep.
and you can kind of view rephrasing of like web text in the same way because you're presenting the same information about the world to the model, but like it's seeing it through different forms of like it's being said in different ways through different text. So I think like that's definitely a way that labs are pushing past the data wall. Another thing is like kind of fusing the phases of training together. Like you have more and more instruct data in your pre-training mix now, even in like early on. I think the pure web text models will kind of slowly come to an end, if not already. Bringing in more agentic things as well, so the model learns things at a more fundamental level throughout the training cycle. I think is going to be useful.
Mm-hmm.
Allows for easier adaptation down the line. Um, they told you again, put out a paper recently on they had domain specific data that they integrated earlier in training, and that ended up having better both downstream performance and less like forgetting when you fine tune for a specific thing. So eventually, all that just gets absorbed by pre-training, I think, in the limit. So I think there's definitely much more room to grow. On the scaling side of things, Blackwell is now rolling out. You're seeing a bunch of data centers come online. Ruben is just over the horizon. So there's going to be a lot of compute, and I think big labs are going to be able to scale more and more. Um, there's definitely like diminishing returns because of the log law, but there's also like capabilities that don't exactly correlate with loss one to one that I think should still show a lot of promise for scaling. So I'm pretty bullish on pre-training surviving and continuing and being strong. Yeah.
Amazing. So there has been a lot of news around mid training side of things. How you'll define mid training, and let's say in this run, how much emphasis has been on mid training? Like I think everything may be like either pre training or on the other side of the things. But if you were to define this new phenomena coming up out of nowhere, and people have different
Hmm.
opinions over it, they define mid training some like it can be towards pre training side of thing, and or maybe positioning side of things as well. So how you define it, and how much it is kind of a concern in this whole model training pipeline?
It's the training you do in the middle.
Yeah.
Yep.
I mean, yeah, I will give a very. I think that just to echo Varun's point, like I don't think that the idea of pre-training saturation, at least from what we like, there at least you see, obviously you have people from OpenAI and Robin and Google and all, they're saying like it hasn't hit a wall, they haven't seen any limits, like,
Yeah.
and it can be easy to kind of shrug those off as like, well, they have to say that because if they say it doesn't, that's a bear signal for everything they're doing. At least for us, I mean, there's not been a single run that we have finished,
Mm-hmm.
or we have not thought, oh, if we immediately went back and did that again, we could make it probably 30-40% better. Like there is always and we're early on relatively in our pre-training, for models, right? Like it's a lot, but nothing compared to your Quins and others who've over the course of all their generations have had upwards of like 120 or 30 models. So um, I think that there are so many ways in which you can further scale up, or maybe scale is the wrong word, but improve your pre-training
Mm-hmm.
performance. That I think that the sky is still the limit there. And then for mid-training, it is. Yeah, I don't know. There's a million different definitions for it. At least the way we've utilized it has been like the last phase. There's kind of we've actually done two. There's like the last phase right before it's where we do our anneal, right? Because we're doing warm up stable decay. So most of the pre training is done on a linear,
Mm-hmm.
uh, not linear, a constant schedule, flat, so that we can decay whenever we want, and you get better performance. It's also what we like to consider our highest quality data blend, as far as like, it is the juiciest tokens we've been able to squeeze out. But we've actually then, for almost every single model we've done, after we do our context extension, we've gone back and done an additional phase of training. In this case, it was, you can measure basically how unbalanced the experts are when you have 256 of them.
Mm-hmm.
Uh, a big part of our paper is like, how do you balance that many experts that are with only four of them activated, right, per
Yeah.
token. And obviously the balance can get all over the place. You don't want to release a model that has 256 experts, but only 100 are ever routed to. You just have a bunch of dead parameters. So uh, that's actually a nice feedback loop, because you're able to immediately start post training, see how unbalanced or balanced the experts are to that new domain shift and that new kind of
Yeah,
assistant and masking regiment, and then immediately go back and do further training to improve that. So um, mid train, we don't have a specific definition I would get of mid training, only that um, it is definitely the training we do that I think has the at the tail end that has a very significant impact on exactly how well we're able to post train.
makes
Yeah,
sense.
I think it's going to become more of a formalized thing. But like a lot of, even if you look at like a lot of Chinese lab reports, there is like a phase after the main long context extension where they expose it to like a lot more agentic and like long form workflow type stuff. And I think that's going to be important because like those kind of have a long context, requirement for the
Yeah,
model to be able to learn that. But like most of pre-training is not done at a long context. So to like really solidify that stuff, I think that's where the sort of mid-training phase is going to come in. I wouldn't be surprised if this kind of like splits up into more and more phases with like more gradual distribution shifts towards whatever your final model capability is like going to be. But yeah, I don't think I still think there's like a wide variety of like what people would consider mid training.
I mean, yeah, makes sense. And I mean, continuing the same deep dive on architecture. So for context, Trinity large is 400B total parameters, 13B activate per token, and 256 experts with 4 active, as Lucas said. So that's a
Hmm.
1.5% routing fraction, which is I think really aggressive. So DeepSeek V3 does 3.13%, and Qwen 3
Hmm.
does something 6.2%, something like that. So you originally aimed for 4 to 420B, but increased dense layers from 3 to 6 to
Yeah.
stabilize routing. What does routing stability actually look like in practice? Like, is it more like expert collapse, oscillating load, or something else? And what do you think? What does this loss curve tell you when routing is going wrong, and how quickly can someone detect it?
Well, I think the tricky thing about routing collapse is that the loss often just looks fine. Like it keeps going
Mhm.
down, evals keep getting better. So
Yeah.
if you're not like explicitly tracking routing metrics, I think it's not going to be like very detectable. And of course, the more sparse you go, the more like prone it is to collapse, just because each expert gets less tuning signal each step, right?
Yeah.
Um, so I think, yeah, I mean, the increase from like 3 to 6 dense layers was one of our like last minute interventions that we didn't exactly have time to like systematically ablate,
Mm-hmm.
but was more of like an educated guess on like, okay, how do we stabilize this thing and get it training well? So that was one of the interventions. Some of the other interventions we did was like we had a new new load balancing method that we ablated at really really small scale, and there was like a few test cases we found where the standard load balancing would collapse, but this one would stay healthy for longer. So
Mm-hmm.
we took that as enough of a signal. We also disabled our like low precision kernels just in case there was like numerical issues there. Um, yeah, we added a Z loss.
Yeah.
We added an sequence-wise load balancing loss as well to mirror like DeepSeek's approach instead of doing a purely aux loss free method. And I think all of this kind of came together to like stabilize not only like full full model training stability, but router stability as well.
I mean, yeah, it makes sense, and this architecture also combines gated attention from Quen paper.
Yeah.
It's like 3:1 local to global attention pattern, where
Hmm.
global layers use NOP and QQNOM. Something I'm genuinely kind of curious about. So, how much of this was ablation driven versus intuition? Yeah,
Yeah. So I think a lot of stuff. You have to like the papers themselves ablate pretty heavily, right?
yeah,
So we chose like even though it may seem like I think risky moves in that like not a lot of people had combined all this stuff. I kind of view it as like we took a fairly safe approach. Like a lot of these strategies had been used in like large scale training runs before. Like the rope to open back again was from Coher's models. They'd use that at scale with Command A.
Mhm.
Um, the Quen 3 ablation, the gated attention results were like super promising, and they'd used it in like I think a 5 trillion token run, something like that.
Yeah.
And we did run ablations on our own on like small dense models, just to like make sure that we were doing everything correctly and that we did see like the intended effects with that, and we only kept the most promising things. So yeah, I think overall it was a very stability and safety, like as in like safety as in like very like not risky um run. I think
I
the
think, yeah,
intuition part came into play mostly with like the load balancing stuff that we were like
Yeah.
in the weeds in the mine, so we didn't have time to like run a whole bunch of ablations. We had to like pick some the highest signal comparisons to do and just kind of choose the best path there.
I,
Lucas, you
I
want
think,
to?
yeah, I just think that something like there's a few notes on that, but when Varun first joined and he was kind of soloing a lot of our initial architecture work, because we always knew we wanted to ideally do our own thing. That's kind of been my um, marching orders at RC. On the research side forever has been like, if the only thing we do is what others have done before, we're only going to be as good as what others have done before. um, we need to be either out innovating or finding something unique to us. And I don't fully think we've accomplished the out innovating section yet, but we've definitely charted our own path. That being said, when you hire extremely talented people who don't have a formal uh, maybe PhD
Yeah.
background in research. Like, one of the benefits of that is they're actually not, they're not as risk averse as what you might have from someone who does come from that background.
Mm-hmm.
They're very willing to take bets and get very excited about trying all these new things. And we certainly have people, Vern included, on the team who are encyclopedias of recent papers. Right, they can chart like a specific paragraph from, a specific. Load balancing paper, to the page and the paragraph. That said, though, like, I think that it's important, and this isn't just unique to what we did with our pre-training, but like whenever we're doing something like this, I think the what I kept saying to everyone was it does not have to be new, it does
Mm-hmm.
not have to be novel, but it does have to be good.
Yeah.
And like even if we did the most unbelievable, fully new non-transformer or attention-based architecture, like if we just pre-trained a single massive MLP, like, and it was this crazy thing that we were able to get, decent performance out of it, it would be cool, but it wouldn't be useful. And at the end of the day, we are a startup that is, venture
Yeah.
backed. We have, we need to generate revenue from the things we make. So usefulness per token, I think, is a metric that I'm trying to get better at quantifying and evaluating. But so it might seem like, with the Trinity architecture was a lot of like, oh, let's just do cool stuff, and we're trying to be different. Almost every single one of those decisions was twofold. One of the ways we were able to do all of these models for so cost efficient is because we don't, at the time, we don't have a massive compute commit
Mm-hmm.
where we're kind of uh, just allocating a certain budget of the GPUs we already have to training. Like we had to get reservations for each one, which meant,
Yeah.
again, we could do it for smaller. Instead of doing $100 million a year commit, we were able to do smaller, 400,000, 800,000, 1.6 million commits on like a time lock basis. The downside of that is that you don't get the chance to ablate at scale until you've actually started it.
Mm-hmm.
So there's a lot that kind of appears when you're throwing that many tokens and that level of parameters and that much data at something, that you just can't ablate beforehand. So a lot of the decisions architecturally were less around like, oh, we hope this gives us the best benchmark accuracy at the end, and more
Yeah.
so like, hey, we're going into doing MOEs We know this is a completely different beast. Um, we also know there's a lot that's not mentioned in these papers about how they keep these things stable. How can we make our best effort at architectural decisions that we're certain are going to give us the best stability we can, both from like a loss stability, so like not a lot of loss spikes, which is a big one, obviously something we're proud of, but also the routing being huge, which again did not really show up in the way that it did for large in mini and nano. Like this was something unique to I
Yeah.
think both the scale of parameters, but also the extreme sparsity we pushed for in large. That I don't think it caught us off guard. We were definitely expecting it to be difficult. The uh, the what did surprise us was that when we started adding in things that others had mentioned in other papers that usually have solved it, it didn't. I think that was when we kind of started to panic a little bit. Was like, okay, or we're kind of getting into uncharted territory of like, oh, we really have to like fix this ourselves. We can't just borrow from what others have done. And I'm proud we were able to do that. But I think we all certainly lost a few years of our lives in those 10 days.
Yeah, I mean, I was reading this paper you published, and there was thing the sigmoid routing with aux loss free load balancing from DeepSeek V3. So you also added this momentum based balancing with TANH clipping on top. So why wasn't the DeepSeek approach sufficient on its own uh, in that scenario, Varun?
Um, so I think the biggest thing to call out is just we had like a crazy amount of sparsity, and we can't say for sure that this is what like throwing this in is what solved our routing issues. Because we did put in like a bunch of changes at once, right?
Mm-hmm.
But we did see it be more effective at like load balancing, like really sparse and like unstable things on a small scale, and we assume that that would carry over to a large scale. I think if you look at the DeepSeek formulation,
Yeah.
it's like a sign based thing, right? Like if your expert is like super imbalanced versus like just a little bit imbalanced, they kind of get the same bias adjustment, which doesn't really which seems counterintuitive. Like you'd want the more imbalanced one to be like reined in a little tighter at first and then kind of relaxed. Um, so the momentum term and like switching to like a magnitude based thing kind of fits that, and you know 10H clipping is just so it doesn't overshoot and is much more stable. Um, and the I think momentum as well. Like if you view it as like the routing bias has like an ideal value that it's trying to reach,
Yeah.
and your job is to help it get there. Momentum in like SGD kind of eliminates noise, gradient noise from each step, right? And it gives like the optimizer an idea of like which direction is like the way to go more stably. And I think in the same way, momentum here kind of eliminates the batch to batch like variance of like oh like because it'll see like different data in each batch, so it'll get a clearer idea of where the ideal expert bias is. Yeah,
Makes sense. I
and
think.
um,
Mhm.
and we had a great team. Fern on our team was like really in the weeds, debugging various setups, trying different combinations of things, and just to land us on this final design. Yeah.
I think to put it in perspective, my rule of thumb is usually like if we're trying to debug something or fix something, do one at a time because
Yeah.
right, if you throw in a cocktail of changes and then it gets better or it doesn't improve, it can be hard to tell what actually is. And when you're debugging anything or you're trying to solve any problem, I think this is true in life, but particularly true for this kind of work is like you need to lower your search space, right? So
Yeah.
um, the load the expert balancing is one, but I think a better singular example was when we were doing mini and nano, but mini was where it was most egregious. We had a period of time where the run would crash deterministically,
Hmm.
and we could not deduce why. And it happened on both AWS clusters as
Mhm.
well as other clusters we were using. And so it would fail. You could restart from a checkpoint, and then it would get to that same step and crash again. Though if you skip that step, like if you uh, basically did a different data uh, you
Fast
shuffle.
forward the data loader a little
Yeah,
bit.
you
Yeah.
basically pass the data loader to a future step. It wouldn't crash, and so we're like, oh, it's data related, but why would it crash on specific data? And every single like we had ablated basically every single option, and it still was crashing. It was actually we had no. It was one of those few areas where it's like we have no idea what this could be. And
Mm-hmm.
I've learned that like okay, if that's the case, it is the tokenizer. Like look at the tokenizer because there's just you don't get as much rich metadata about how something's doing from the tokenizer as you do everything else. And it did end up being our early tokenizer was having trouble with extremely long sequences of numbers, and we
Mm-hmm.
had pre-training data, that was large sequences of numbers that was like catching it and causing it to hang, and then it would crash. But in order to deduce that, you need to lower your search space. So instead of trying to solve it across the entire training pipeline, try it with different data, right? Immediately that tells you like, okay, then it's probably data related. If that fixed it, we had the same thing with 4.5b where our loss was not going as low as we thought. The
Mm-hmm.
evals were not going the way we wanted. We swapped out our own custom tokenizer for llamas, and it did work. And so we went, okay, it's a tokenizer issue. Lowering your search space when debugging is extremely important. And so, obviously, harder to do when you're at a 400B scale, right? And each experiment is costing upwards of 30, 40, $50,000.
Yeah.
Each one can feel a little bit more pivotal than something at like a 4.5B scale, but um, I'm glad, what ended up working was we were kind of hitting the point of no return where like we needed to get the run going at full scale, and we had about 4 or 5 fixes that to ablate each individually would probably take 2 or 3 days, and we had good results from each of them. So we kind of just said, all right, screw the rule, throw them all in, and that luckily ended up fixing it. So it's also hard for us to say which one had the biggest impact, but we can state that like these all at least work together, and is something we're likely going to carry into future runs.
I can imagine it, and I think it has a lot to do with iterations and experimentation, figuring out a lot. I mean, also you guys are one of the first to use Muon optimizer at scale instead of Adam. So this moonshot paper showed roughly 2 times compute efficiency. So did you see that same multiplier at your scale as well, on 400 billion total 73 tokens, or does the advantage looks different as you get bigger?
I think it's impossible to say because we couldn't do a full Atom versus Muon run at that scale.
Mhm.
Um, but I think it's safe to say that Muon is like more data efficient. How much more data efficient? I think is still up in the air. Like there was a fantastic pre-training optimizers and find them paper that sort of I think ended up at the conclusion that it was only like up to 10% better, which is still good.
Yep.
Um, and then yeah, like you said, Moonshot found a 2x. So I think there's like a pretty. I think it's unsettled as of yet, at least in the open.
Yep. And also there's a lot of Muon variant work happening. There was this Muon NSR, VS, EQ, Adam Muon. I was surprised when I heard Adam Muon, Nor Muon, and a lot of them. So are you tracking any of these and trying anything beyond vanilla Muon?
Only on small experiments so far.
Hmm.
I do think there's probably something that like Normuon looks really promising, but we have a lot to test at least. Yeah.
Yeah, and I think it's worth like I don't know. I mean, this is a lesson that I've certainly had to learn, and I'm hoping to is being somewhat you know tricky trickled down into the rest of RC, but
Hmm.
just most of the people we work with is that like there can be an impulse when a new paper comes out or a new report or any new kind of paradigm shift, potential paradigm shift to so like for instance, if you're doing pre-training and you're doing Atom, which is what we used for the 4.5b, right? And where you're struggling to get good performance out of your model, or at least what you want. Say you have an accuracy target you want, and you're trying to get it to 60 mmLU or something, and it's hitting 55 on Atom. The impulse could be, oh well, let's try Muon, and maybe that'll get us to 60. And while it very well might, I do think that the idea of reaching for new training like training regime changes or pipelines is, I think that sometimes can often be a long-term mistake, in that like fundamentals is the most important thing here, right? Like what makes a good model, which is like stable training, being able to distribute that across many many machines and scale up, really good data, and then like not basically burning the model with your learning rate or your scheduler, and getting as much throughput as possible, so that given a certain compute budget you can get through as many tokens as possible. Like we could train on a massive amount of compute, but only get through a very tiny amount of tokens if you're not able to do it quickly or efficiently. So we try to be as pragmatic in these decisions as possible, and that like, hey, are we making this choice because we're trying to solve for something else that we're not quite sure of? Then maybe we should think about not doing it. Or if it's like, hey, we're making this choice because we've already kind of saturated the fundamentals that we're already at, and we're looking to take ourselves further. That's where I think adding in a lot of these newer, kind of more cutting edge decisions makes sense, or regimes and architectures and algorithms make sense. But I think that using it to solve or band-aid over a lack of capability is fine, but then you're always going to reach the point where, to eke out the performance that you want, you're going to have to go back to the fundamentals,
Mhm.
and those are definitely the things that benefit the most from like reps, like just doing it more, iterating, improving, and so you're going to have to do it eventually. You might as well do it up front.
You mentioned about data. So my next question is about data curation. So 7 trillion tokens were distributed across three phases: 10, 4, 3, curated by Datalogy. Over 8 trillion synthetic, if I remember. So that's close to half the training data being machine generated.
Yeah.
So the model collapse concern is there. Like, what guardrails do you actually use? How do you verify that synthetic data is helping rather than reinforcing the model's existing distribution?
I mean, one of the that's a I mean, it's a relatively easy thing to validate. It's a little bit harder to
Hmm.
understand the nuances of, but like obviously doing ablations where you pre-train like the exact same setup, exact same model, exact same tokenizer, everything. Just do using that with a synthetic component as a comparison, and if the synthetic one scores higher, in the areas that you care about, then you can somewhat deduce that it's at least working.
Yep.
So yeah, I mean, I think that working with datology and focusing a lot on the curation and the synthetic side of things, I think kind of goes back to that idea of like, if we just do what everyone else is doing, we're only going to be as good as what everyone else has done. If we wanted to release something that we felt was truly differentiated, and at least give ourselves the best chance at rapidly upskilling ourselves on pre-training, that like focusing on that was going to be pretty key. So yeah, I mean, there are certainly areas where you can go overboard with that. Like you can definitely see the ratios. I'll just put it this way: the ratios are very important when it comes
Yep.
to synthetic data, and not just how much of it is synthetic, but also how sometimes it's more beneficial to do multiple repetitions over a smaller corpus than it is to do a larger corpus, right? So instead of doing, you know, 500 billion tokens of all new data, you do, two epics over 250 billion of higher quality, and all of those ratios and those all interact with each other. So like the number of synthetic versus the number of web text non-synthetic repetitions versus synthetic repetitions versus it all has this
Yeah.
very kind of like nuanced it can be very tricky to do
Yep.
right. So,
And also, I mean, there are many such vendors for this data. So if I have to ask, let's say there are five vendors, what are the two pointers, or like would Lucas see, and to see the data quality or something like that, and go after that. Let's say not just datalogy. Let's say five of them are there, and you have to see. I mean, what does really matter when you are using the kind of data?
there's I would say that datology is pretty differentiated compared to like there are a lot of companies that do data.
Yeah,
Certainly,
yeah.
I mean, I think, but that's also tricky because like data is an inherently umbrella term for a lot of different things. You certainly see a lot of post training SFT and expert data companies. Like Scale was obviously the
Yeah.
first to really kind of scale that up. I guess no pun intended, but scale that up. Mercor, is doing well with that, and then you're seeing a whole host of players doing like RL environment work, which you could also consider like a in the scheme of RL post training, that is very much a data level thing. There are certainly other players like Datology that help provide and um, get high quality pre-training data. I think that you see a lot of there are some companies out there that specialize in like licensing and selling data that
Mhm.
is like from companies that either went under or don't have a need for this data to be proprietary anymore, and it's like some unique thing that's not kernel like credit card data and finance data and insurance and like anonymized medical data that isn't just available on the web that they work with to license and sell for people to try to like get more diverse data
Mhm.
inside of their pre-training. But you know I don't know, I think if you're looking at it ultimately like it drives my the marketing and a sales team nuts when they ask me questions like that because it's like everything depends on the context.
Yep.
uh, Datology was right for us because we knew that we wanted to do a significant amount of pre-training with a significantly smaller budget than our peers, and we had to be very effective with where that capital went and how it was allocated. We also knew that we wanted to do a smaller amount, relative to our peers. We wanted to do a smaller number of tokens, at least for 4.5 being mini and nano, and try to achieve similar performance while we were kind of getting our training wheels for figuring out how to do a large scale run. Um, so it entirely depends on what your needs are, and the answer could be a little bit different. Like if you're just wanting to do post training on top of another open base model, there might be other people who are better for your needs. If you're wanting to do like significant amount of mid training to then do post training, could be someone like Datology, could be someone like us. If it's just like, hey, let's make a optimized version of Trinity. It can be extremely um, hard to find the right person, and ultimately you have
Yeah.
to trust your gut.
I mean, I really think there is some, I mean, could be alpha drop in spend with this partnership between RC, Datalogy, and Prime. Well, uh, so how are you handling reasoning evals? It's synthetic data or curated? Because the pricing you offer is very competitive, but matters if accuracy holds on that side of things.
Mhm. Uh, how do you mean event? Like I don't
I
know.
mean,
Can you
yeah,
just
for the reasoning model, I mean, I'm
yeah?
talking about evals, yeah, normal benchmarks.
Um, it used to be a pain in the butt to eval reasoning models.
Hmm.
I think that was when you approached it the same way you used to evaluate like SFTs or even like RLHF data. Or RLHF, post train models, where it was like, hey, we have it on a single node. We're
Yeah.
going to spin up, LM eval harness from a Luther and load it using the transformers backend to do a bunch of log likelihood evals and then, report the results. Um, it's actually not that tricky once you get it, because the whole point of like Trinity has always been to serve it, right?
Hmm.
We want to make it open weight and allow others to use it with a permissive license, but we've always wanted to serve it and have our own API. And a lot of these newer, especially reasoning evals, or just most evals nowadays, are generative, right? They're not log likelihood. Some of them can be both, but
Yeah.
since they're generative, as long as you're able to parse out the reasoning content, which if you have a good reasoning parser, it kind of happens automatically. So it's actually not that hard. It definitely takes a long time though. I mean, AI. This was something that was when we were doing RL was tricky because we were trying to eval rather
Yeah.
often,
Yeah.
and for stuff like AIME, GPQA, on really hard problems, these models think for a long time, and the
Mm-hmm.
longer they think, the more tokens they're taking up in the context length, the
Yeah.
slower they get at generating each token, and you can get to a world where like, hey, out of the 198 GPQA diamond questions, it
Yeah.
will have answered 193 in 45 minutes, but then the other three are going to take 2 hours. Like, so it's definitely, we stand to improve on the efficiency of our evaluation so that we can be a little bit more iterative, but we didn't struggle with getting them to run, I guess. It's mostly like picking which ones you care about.
Makes sense. I mean, and this is pretty subjective to models and I guess people as well who are experiencing that model. So what do you think could be better optimal solution to this? Because this is the same case for like years now. So I mean, on the eval strategy sort of things, what do you think someone could optimize for?
I mean, I think we need better. Frankly, this has come up quite a bit, um, beyond just research as we get into commercializing Trinity at scale. But
Mm-hmm.
I think that something that's extremely important is that the models are getting extremely good at extremely hard benchmarks.
Yeah.
Like, even taking Trinity aside, if you look at what Gemini
Yeah.
and OpenAI and Anthropic are doing, like these models are getting extremely good at stuff like frontier math, right?
Yeah.
From um, Epic, which is like a level of math difficulty that I would say 0.001% of the population actually can understand. Like, it's not. This is not it is a great indicator of how good these models are getting and how smart, but the
Yeah.
usefulness to your average consumer is actually quite low. So I've even gotten to a point myself with someone who uses these models all the time where it's difficult for me to judge how good a model is on the use cases I work with, because to a certain degree the improvements in your day-to-day work are getting smaller and smaller because they're already quite saturated.
Yeah.
So like it might get 20% better at frontier math, but if I'm doing slide generation and I need the model to be really good at writing like a specific HTML or like a specific TypeScript library to generate these slides for my customers, yeah, it might get 30% better at frontier math, but only a couple percent on the thing I care about. And so I think more than anything, the ability for people to create their own evals
Yeah.
easily, and then validate that the metric that automated eval is evaluating is accurate to how I to the tastes and things that I want it to be good at. That is an area that is, I think, a little not maybe not underexplored, but not as mature as it needs to be. But I think going into the next few years, like not just companies or developers or startups or enterprises having their own internal, but like individual users having a set of even if it's just like 20 to 30 questions that are kind of like how they evaluate how useful models are for them, because it's going to get very hard to deduce how good something is for you or if it's cost efficient for you if you're just looking at the reported evals coming out of labs,
Yeah.
because those are going to be measuring levels of intelligence and competence on things that um, are largely irrelevant to the day-to-day work that a lot of us do.
Makes sense. And continuing with the similar lines, the next hop is how much inference engineering has played the role in this run. The kernel development and optimizations over that. What's the alpha out of there?
There's two sides to it. I think Varun can speak a little bit more to the the post training side of it, which was actually uniquely
Mm-hmm.
um, difficult because we were at the time only really able to get a lot of H100s, which is cool that we
Yeah.
got them. but not optimal for Trinity because it doesn't, at full precision doesn't, or at BF16, right, doesn't fit it on a single node.
Mm-hmm.
So in order for RL, we did have to do multi-node there, which um, we was slower with the way that we had to do it and the amount of time we had to optimize for. Definitely, I mean, for serving our customers, it has been we're having to learn that just as much as anything else. Like, we're doing almost all of it in house now. We're not using a
Yep.
provider. We're not going through someone else. So, we are spinning up these VLM and Dynamo and whatnot on our own clusters. And with that is great because you can be pretty cost efficient. You're cutting out a lot of like the middleman tax. The
Mm-hmm.
downside there is that a lot of the things that these companies spend their entire uh, you know uh, fundraising capital on improving, we're having to do ourselves. So definitely improving like tool use, reliability across different weird open AI API nuances
Yeah.
is for speed running. But I mean, it's nice. Inference is one of those things that, like, similar to training, like if you can get a 5% improvement in throughput, you can serve 5% more users and you can
Yeah.
make 5% more money. So it's actually a
Yeah.
fun problem to optimize because it's the rate at which you optimize is directly correlated to the rate at which you're able to make money and serve more users.
Makes sense. Also, before going to questions on positioning and moments, so this is a kind of, you can say, quick fire questions. Maybe one or both of you can answer. Um, so most overrated technique in LLM pre-training right now. Um,
Most
what do you think?
overrated?
Yeah.
Uh,
Next token prediction. Okay.
that's actually a tricky one.
Or maybe if I have to reframe, would you go for diffusion over autoregressive? If I mean, what do you think of it?
I don't think diffusion is overrated like diffusion LLMs. I think they
Mm-hmm.
still have a way to go, but
Mm-hmm.
I mean, it's difficult to deny how fast the inference is, you know.
Okay. So let's pick a very general question. What's the one arena, domain, field, whatever, where most of the people are sleeping right now, which gonna be matter in upcoming 3 to 6 months?
Mm,
I feel like if we knew the answer to that question, we wouldn't tell you. Just because, and I think I'm joking, but I'm also a little serious in that, like, it's important for us to, as we want to continue doing this as a business and do it sustainably, and like make sure that there's value in us being in the market beyond just like, I always said, like, if our only value prop is that we're American,
Yep.
like, cool, like that's novel, but it's not gonna, that, and it might be for some very specific use cases where people can't use Chinese models, or even models out of like Europe, and then sure, but it's not. There's no reason for us to be here if that's our only value prop.
Yes.
And so, if obviously the model needs to be really good at agentic, like Openclaw and
Mm-hmm.
your Hermes agents and your kind of always on models. I mean, harnesses, like we said at the beginning, but
Yep.
um, also needs to be really good at coding. Like, people love coding, but I think that over time, like, if with the small team we have and the somewhat limited resources we still have as of now, is the biggest return on our investment speed running becoming the best coding model in the world when we know that there are billions of dollars going into that out of
Mm-hmm. Mm-hmm.
basically all the closed labs? Or is it more worthwhile for us to find something that we think we can be uniquely good at, that is still serving a vast majority of your kind of like total addressable market, and people using LLMs? And we think the answer is yes. We think that obviously, we need to be good across all things that people want these models to be good at: coding, agents, tools, everything. But figuring out what is RC going to be uniquely good at that others either don't have the time to put into it, don't want to, or can't for whatever reason, is important. And we have some ideas, and we have a lot of things where we're testing out, and a lot of that comes from users, right? Like, what do users care about and the feedback we get from them, and what are they missing in the market that isn't prioritized by other players? But um, I do think one of the the biggest things across all models, like even closed or open, is like long context
Yeah.
adherence in the agent world. I think that a lot of the benchmarks for that are particularly driven for like retrieval back when it was, you're dumping like Harry Potter books into context and asking it to, do like a needle in the haystack, find something that's wrong. That works for the old way of interacting with models, but a vast majority of the tokens that end up in a model's context nowadays are generated by the model itself or tools that it called. And I think that uh, not just the evaluations for how well that models do under that paradigm are lacking a bit right now, but also the ways to improve them. So certainly work there.
Yeah, totally makes sense. Let's get back to the post-training stack. And I'm curious about preview to thinking. So preview was a non-reasoning instruct model with light post-training, and thinking came about 2 months later as the full reasoning model. So you have written that reasoning variant was very intelligent, but not yet maximally useful. So what does that actually mean in practice? Like what does
Oh,
that reasons well but
yeah.
isn't useful? Like.
Those were that was in reference to why we did preview. So
Oh,
when
okay.
we had prepped a pretty big pretty massive actually reasoning corpus for large. The initial intention with Trinity Large was to release. We were always going to do a preview. We always knew we weren't going to have time to get to the level we wanted in the amount of time we had. But it was to do a thinking model because many had been a thinking model, and we kind of wanted to position all these models as reasoners first. But what I said in the blog launch for preview and Trinity Large was we were able to make the model really good on benchmarks, but we weren't able to make it maximally useful. And that, like, it might look good on a graph, but when you go to play with it, like if you say,
Yeah.
"Hey, what's your name?" or "Hey, what's the meaning of life?" or "How many, R's are in strawberry?" If it thinks for 40 to 50,000 tokens before answering, like it's not useful, you know.
Yeah.
And I think that was what we were ultimately. At least I was nervous about putting that out into the world because I think what's most important for RC in this moment is to be building things that are useful and people actually use. So we did. We kind of pivoted to the instruct model because we've done a lot of that before. We have a lot of experience. We have a lot of people on the team who we kind of have that data and training regime locked and loaded. But for the thinking version that was released last week, there are areas I definitely think you still would want to use something like an instruct model, especially in like storytelling, creative writing, long form, like Dungeons and Dragons type games. Like Preview's really good at those kind of things.
Yeah.
But the idea of I do think we hit a nice middle ground of thinking. The Trinity Large thinking we released last week. It will think rather short for things it doesn't need to, and sometimes too long for things that it does. But a significantly better balance than what we had back in January.
I mean, on the same line, there is emerging consensus on RL environments. So I'm curious about because a lot of these people from big labs kind of coming out and building their RL environment companies across anything like you mentioned about long horizon tasks, computer use, GTP val, MCP, and all these stuff. So when you were building the RL pipeline for training, so did you build your own stack for environments or relying on existing harnesses? Openclaw, Clino, Kilocode, whatever. So, how do you think about environment design as a post-training concern right now?
I'm so excited to actually get to focus on it. I think that we've spent the last, I guess, 8 months now solely like we have not had there's not been a moment in the last really year, frankly, but especially the last 8 months where there has not been a model training in some fashion that is very consequential to the future of our company.
Oh wow.
And it that's a gift. Like a lot of people would love to be in that situation, but the side effect of that is that we had to make decisions that worked for what we were doing the next day and not what we were doing the next week. So um, we used environments and from across all over. We did source some from providers. Not all of which ended up making it into the final run, just because when you're at the cutting edge of working with some of these really great companies, like the infrastructure in order to do that on top of everything else can be tricky. and that's something we're excited to scale. We also use some pre-existing ones, that were like on the environments hub from PI, and then we had quite a few that we'd built out ourselves. So it was a nice mixture of kind of like all of these different, all of it's kind of the beauty of open source kind of
Yeah.
showing itself there, where we could take what we wanted from what we knew we wanted, we could take from what existed and what was unique to us, we could build ourselves, and then we could also work with providers. So it was a nice mix. But certainly from environment design, like I think there's so much alpha there, and the
Yeah.
ceiling is so unbelievably high. The ceiling's so high on the model itself too. Like this is not the best possible Trinity large, right? This is the best possible Trinity large we were able to do after pivoting from pre-training to post-training in 2 months. There is a significant distance to where we can take this base model and future models. So we're very excited. This is kind of like the first week where we're actually kind of going to be able to like sit back and take stock of what worked and what didn't, and what do we want to do over the next couple months to take ourselves even further.
So there's one friend of mine who was asking, I mean, about harness bias question. So you use open code as a harness in dataset construction, right? So does that mean Trinity works best specifically for open code? So there are other coding agents gaining traction, PyAgent, Hermes. So are you experimenting with capturing trajectories from multiple harnesses, and how much does the harness choice actually matter for resulting model?
We didn't in the final run, actually, both SFT and post training. We ended up using a lot less of the open code traces than we initially had intended to. There's a few reasons for that, and none of it is like they were bad, or I think it was just the scale at which we had versus the scale at which we needed was actually quite different. There is something, but to answer your question, like point blank, like no, it's not going to be better in open code than in Klein or Kilo or anything else. We do think that there's a pretty generalized agentic harness ability with this model. And there's also a lot of work you can do, like if you generate traces with open code or Klein or Hermes or Openclaw, there's a lot of work you can do to like
Yeah.
rewrite the prompts to you can basically like give it, if it had the open code prompt, you can rewrite it with the Claude Code prompt or with the Kilo prompt. Like there's ways in which you can take trajectories from a single harness and generalize them to a bunch of different harnesses, which I think is
Yeah.
important. Yeah, I mean, I think that overall, I'm glad that I see the consensus on Twitter being that like we need better agentic
Yeah.
traces, and I'm glad that that's happening, because not only is that true, the infrastructure around doing it properly needs to be built as well.
I mean, yeah, makes sense. So I guess we are pretty much end of the pod, and my next question will be around the open source and competition around. So you have written that that permissive American converts are necessary for the US to fully claim its leading in AI. But the
Yes.
strongest open models, I mean, which are kind of state of the art, are also coming from Chinese labs, like from the likes of Minimax, DeepSeek, Quent, GLM, and all. So, and also Epoch AI says that the gap between open weight and proprietary models is about 2 to 3 months now. So I mean, is US actually behind in open source? Do you really think about it?
We're certainly trailing our Chinese competitors. I mean, I think that's even though you know we were delighted that we were able to show Trinity as competitive as it was in the
Yeah.
benchmark we released. Like, there's obviously there are areas where we stand to improve drastically, and I think that the goal here is like you know we had all this momentum to get here in such a short period of time. We can't let up on that. We can't let ourselves get sloppy. We can't let ourselves, now that we released a good, what we would consider frontier level model, to
Yeah.
like, just chill out. No, we need to, if anything, put the pedal to the metal quite a bit more. Um, I don't know. I mean, I don't want to. I could wax poetic about why I feel that the idea behind, about open models being behind frontier models is actually a poor way of framing it, because they serve uniquely different needs in the industry. Especially if you look at model intelligence as an aggregate for how much compute went in roughly. the closed providers are about to explode with the amount of compute they have coming online, and so I think that if anything, that gap might get larger if you're viewing it purely as a like how many months behind on evals are they? But when viewed as as I said earlier, those models are getting good at like super intelligent frontier, you know, 99.99999% of humanity has no need for it to get good at this thing. Um, Whereas the vast majority of people who are utilizing LLMs need them to be fast, reliable, cheap, and proficient for their exact use case. I think
Yeah,
that's where open models are going to win long term. Like if you look at every product out of OpenAI over the last year, for the most part, they've all had a custom model as a part of it, right? Deep Research was the first agent that kind of blew people away. Codex was custom variant for coding. They've done that with their agent, their computer use stuff. All of it's a custom variant on top of their GPT-5 model. So if they're doing it, if they've found that the best way for them to make sticky and leading products is by merging the customization of a strong base model with the development of a powerful UX and harness, I think everyone else in the world should be paying attention to that. And in order to do that, you're going to need strong open models that are extremely good at being customized towards downstream domains. So, yes, on raw benchmarks, there's still some room to go. Not as much as there was a couple months ago, but still some room.
yeah.
But long term, I think that the I think America is going to have a really robust open model ecosystem. Took us a little bit after Meta. We just need to make sure that we're never so reliant on a single provider ever again.
I mean, yeah, after after Llama 4, I'm not surprised enough actually. So, man, I was really surprised by the adoption. So, about 3.3 trillion tokens served on Open Router in just 2 months, and
Yeah.
being number one in the US. So, I'm just curious about what really drove that adoption and what were people mainly using it for.
I mean, it helps. It was free. That certainly helps. And that's something that I think is brought up quite a bit as a like, oh, well, it's free. Of course, people used it. There's a lot of free models on OpenRouter.
Yeah,
You know what I mean? That don't end up getting used. Like, it can be free, but it can be garbage. People aren't going to use it. Um, I mean, I think that funny enough, one of the things we were scared about releasing an instruct model, right, is like when people post benchmarks against their competitors, you don't usually like differentiate between instruct and reasoning, right? Like if they're showing us against Minimax, they're not going to say like, oh, it's an instruct model and this one, is a reasoner. So, there's a little bit of a concern there, and people can kind of like look down on something right away when they just see a graph that maybe might not be as pleasing towards us. But I think people forget just how great instruct models can be and how many use cases there are for something that doesn't do a ton of chain of thought and just answers really, really fast and does well at tool calling and can handle multiple turns with a high context length. So I think if anything, right when this kind of Openclaw thing blew up, people being able to just like ping it and have it immediately answer instead of waiting 3 minutes for it to come back after its chain of thought was kind of like a breath of fresh air. And I think it was just kind of right place, right time.
I mean, yeah, that makes sense. And pretty much what's next now? So Trinity to Nano and Mini are coming with distilled knowledge from large. You have said the project becomes even more ambitious.
Yeah.
So what's the biggest technical debt, if I have to ask, you're making in next 12 months? Also, like, the gonna be focused on multi-model as well, or just be like just scaling on LLMs only around various harnesses, agent and stuff.
I have several people that I hired for multimodal work who have since
Oh,
been
damn.
doing a lot of text based work. So I need to get them, and they need to start working on the thing that they're excited about, although they've been lovely and are very talented across the board. Yeah. Yeah. I mean, we need to get pretty good at multimodal, especially vision. I think there's kind of some, not low hanging fruit, but the next obvious thing for us. I mean, I think the biggest thing we have to do is just vastly scale up our infrastructure. We need to bring on some new people. We need to have a kind of consistent compute cluster that we're able to do, more persistent and regular experiments and ablations. So there's a whole bunch, but this is this is the year of infrastructure for RC. That's for sure.
Yeah, makes sense. I think this might be my last question, and it actually is combination of two questions. So first is, what do you really look for when you're hiring across, let's say, on the research role? And on the similar lines, what someone who is just 20-year old starting out college or in school should actually go for in the current space of how the things are evolving, because there's so many things going on apparently, and how the traditional universities are, so it's really hard to adapt to the current state of the art and the frontier stuff. So yeah, I mean, in terms of hiring and advising to people who are just starting out stuff, and I mean, what should they actually look forward to?
I'll take
And
the
I would
hiring.
like to answer a question from both Lucas and Varun on
Yeah,
this.
I'll take the hiring part, but Vern, if you want to think on the,
Yep.
because that second question is
Yeah,
actually quite tricky.
it is tricky.
And I've had to answer it for a few people, and it's one that I don't think there's a one right answer for, but there certainly could be a few wrong ones. As far as hiring, I mean, intuition, problem solving, and passion and ambition are definitely the things I look for. Obviously, you have to be decently um, capable at navigating and understanding the nuances of what we're doing, both training and just ML in general, and then the downstream use cases of them as far as like agents and products, and how do you take something that is inherently a next token predictor and make it something that is driving a bunch of ROI for a customer. Easier said than done, but it is absolutely like problem solving and ambition and intuition are extremely important. There's no way to teach that. The only way you learn that is by, as we said at the beginning, picking unbelievably hard things to do that you have no business doing and then still doing them anyway.
Hmm.
That is how you build up all of those traits. There are a lot of things in these training runs that helped because me and the team had built up a really great intuition of what looked good in post training or pre training and what didn't,
Yep.
and we could intervene early. So I really do think it's just do things and look for grants and try to get compute sponsored, or see what you can do to run experiments. Do it on your 3060 in a Google what do they got?
Collab.
Google Colab, yeah, like just do things. Read as many papers and get as knowledgeable as possible on paper, like book smart. But the real alpha and the real hireable trait is someone who learns through doing.
Yeah.
Yeah, I think for like what people should focus on, I think there's kind of like a twofold problem there. One is like things keep changing all the time.
Yep.
With
I think
AI,
this was
like
the
every
biggest problem.
yeah, with AI, like every day there's like five new things,
Yeah.
all developing in parallel. So there's like a lot to keep up with. So that can be kind of exhausting. But then also I think there's like a lot of new things out there that like exist now because of all these developments, right? That like you just don't get exposure to. Like you won't know what's out there to even like look for. So I
Yep.
think one of I think one of the things that's helped me personally is just kind of like being very like exploratory in that sense, just like seeing what people are working on. Like you start from like something popular, like maybe Llama 3 Tech Report. um See what like maybe find one specific aspect of it that's like catches your interest. Maybe like the infra on like how to prevent downtime or something during a big training run. How to prevent a Linux update from crashing your whole run, right? Um, Maybe you get interested in that, and then you see like what people do about like fault tolerance and things like that. A lot of it is just kind of like just not being afraid to like jump to like the whatever frontier, pull the paper, kind of just explore. And I think that bit of exploring is probably like once you start with that bit of exploring, you kind of will find something that you're like really passionate about learning and go on through that
Yep.
way, I think. So I think
And
exploring is probably the biggest device. Yeah.
if people are looking specifically at like, oh, I'm 18, I'm going to go to college. What do I want to major in, or what do I want to specialize in? I think a pretty safe bet is that like platform and infrastructure engineers are going to be in very, very high demand over the next 5 years.
Yeah.
Even as these models get really capable, it's going to be very hard for companies to fully automate and trust the agents across that entire pipeline, because it is an extremely important for resiliency and making money. So if you're looking and you do want to do CS and you're afraid of LLMs taking or reducing the number of jobs available there, which is a different topic, I would say that getting quite good at managing cloud and training infrastructure would be a safe bet.
Makes sense. Okay, Lucas and Varun. So, what is one thing you guys really think that is the main blocker right now in the whole? I mean, in this space, and what is one thing which you guys are most excited about to happen in, let's say, in a near pipeline?
Biggest blocker out there right now is that there's no GPUs available anywhere, and it's crazy.
Yeah.
I wouldn't have expected like H200s to like suddenly go out of existence, but like they have. So in a sense, yeah, GPUs are our biggest blocker, I think. But and things to look forward to, I think, are going to be. Um, I think in like the whole AI space, the whole like this year, there's a lot of data centers and a lot of compute capacity coming online. Um, I guess that's the same once or twice with just GPUs, but the stuff that's going to enable in terms of like scale and how far labs are able to push that stuff, I think we'll see like a pretty crazy year in terms of capability increases. Yeah.
Mhm.
Do you see how much Varun has become a flop head in the last year? GPUs, GPUs, GPUs. Um, I think we're very close to this year being in a world where um, most individuals who take make the effort in kind of integrating AI properly into their daily workflow are going to be able to get some pretty massive boosts. For a long time it was largely technical players and coding and obviously those were necessary, but we're getting to a world where with Claude, Cowork, and stuff like you see a lot of the labs specializing in Excel and less so. You're losing the even assistant agent paradigm where it was like, hey, help me schedule this meeting, and you're getting into the like actual being useful in the total in a large consumer base of people's like day-to-day work. And I'm very excited for that to happen. I think it's very important that it's done properly and
Yep.
that there's a great education around how to use AI and when not to, and how to not over rely on it. I think that's probably one of the biggest risks in the short term is people getting, I wouldn't say AI psychosis, but people becoming over reliant on it and believing that just because it has the word AI in it, and in science fiction AI is this massive omni intelligent thing. Well, we're not there yet, but I'm very excited for this to become a much more distributed benefit. I think we're very close to that.
Pretty much so are we, and I think we are on a closure. And this was a really great conversation. I mean, we have covered everything around pre-training, post-training, open source, data curation, agents, harnesses, and I mean pretty much everything. And for the people listening, you can try Trinity Large Thinking right now on the API at Chat RC or on Open Router,
Yeah,
and given all the weights are on Hugging Face under Apache 2.0. And if you want to work on this kind of stuff, maybe approach any of them. So Lucas and Varun, thank you so much for coming on. This has been a great conversation. Hope you guys have enjoyed this too.
it was lovely. Thanks for
Absolutely,
having me.
yeah. Thanks for having us
Amazing.
here.